Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 9 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 865. Smallest subtree with all the deepest nodes. Right. So in this problem you are given the root of a binary tree. Right. The depth of each node is the shortest distance to the root. We have to return the smallest subtree such that it contains all the deepest nodes in the original tree, right? A node is called the deepest if it has the largest depth possible among any node in the entire tree. The subtree of a node is a tree consisting of that node plus the set of all the descendants of that node, right? Okay, see this, understand this with an example here, right? So here this is your tree, right? So first 3, then you have 5 1, then you have 6 2 0 8, right? And then you have null null 7 4. Okay, null null, then null null, and then 7 4. Okay, that's it. So this is a tree given to you, right? Clear this part? Now here this root is having, let's say, depth 0, right? So this one is having depth 1, this is also at depth 1, right? This node is at depth 2, same way depth 2, depth 2, and depth 2, right? This node is at depth 3, this node is at depth 3, right? So these two nodes are the furthest to this root, right? To your root, right? Now 7 and 4, they are the furthest nodes, right? And their common parent is this 2, right? 2 is the ancestor of these, right? Right? So what we need to do here? Okay, so a subtree of a node is the tree consisting of that node, right, plus the set of all the descendants of that node, right? And a node is called the deepest if it has the largest depth possible among any node in the entire tree. And we have to turn the smallest subtree such that it contains all the deepest nodes in the original tree, right? So see this 2, this part, this yellow colored, right? So this, if I write it, yeah, I'm going to write like this 2 and then 7 and 4. So this 2, right, the subtree starting from 2, it contains all the nodes, right, which are having the highest depth, right? We have to return the smallest subtree such that it contains all the deepest nodes in the original tree, right? Okay, so here we return the node with the value 2 colored in yellow in the diagram. The node colored in blue are the deepest nodes of the tree, this blue, right? Notice that the 5 and 5 3 and 2, right? Notice that 5 3 and 2 contain the deepest nodes in the tree, right? This path, right? They contain the deepest node 5 3 and 2, but node 2 is the smallest subtree among them, right? So we return it, right? So this 2 is the common, right, which contains both the deepest nodes, right? Now if instead of this 4, if I just write null here, right, that simply means when I'm going to draw the tree, it is going to look like this 3 5 1, and then 6 2, here 0, and here 8. We have nothing here, null null, then here we have 7, and then here again null. Okay, so now here see, this is the deepest node, this is the deepest node, right? So in this case, can I return this, right? Because this 7 is coming from this 2 path, and then 5, and then let's say this root. Okay, so can I return here 2 7? No, I can't, because 2 only contains 7, right? But there is nothing here, right? So in this case, I just need to return the 7 only as output, just 7. Note complete. Clear this part? So here it was valid because here 2 and here we have 7 and 4. Okay, but here in this case it is not valid. I can show you one more example here what it is doing, right? So here you see this example 0 1 3 null 2, 0 0, 1, 3, and then we have null, and then we have 2 here, right? So in this case, I'm simply going to return this part, 2, that's it. Here, 2 is containing all the deepest nodes. So here in this case, I'm simply going to return the 2, that is the deepest node, right? But there is no common like this here, right? So here if you see in this case, only 2 we are returning, right? The deepest node in the tree is 2. The valid subtrees are the subtrees of node 2, 1 and 0, node 2, 1 and 0, right? But the subtrees of node 2 is the smallest, right? The valid subtrees, okay? And a subtree of a node is a node is a tree consisting of that node plus the set of the descendants of that node, okay? Clear this part, right? Okay, so this is what we need to do, right? And these are the constraints, right? So how we are going to solve this problem, right? So let's see that. 3516208 null null 74, okay, like this. So what you need to do here, you have to simply call the DFS, right? The helper method, right? So at the root, right, at this point, what I need what I need the deepest node, right, and the depth, right? Two things I need: the deepest node and the depth, right? From this side, what is the deepest node and the depth, right? Okay, these two things I need, right? So I move here, let's say 5, and after that let's say I move here 6. So in this side there is nothing, right? So what I'm going to do here, nothing, right? Both the same. So from here I will just simply return node 6, and the depth of this is just 1, okay? Let's say 1, right? Because from here to here I'm moving, right? So 1 distance, okay? Clear this part. Now same way I need to solve this part. I move here, then I move here, let's say, okay? Then here there is nothing, right? There is nothing. So from here I will just return 7 and the 1, okay? 1 distance. 7 is at 1 distance from this 2. Same way here 4 is at 1 distance, right? I am returning node 4 which is at 1 distance to this 2, okay? Here I go, there is nothing, right? This is what I'm returning here. Now see here, this is 2, right? So here the distance is 1, here the distance is 1, right? Same distance, right? Both are same. So for this common node, right, common ancestor, right, for 7 and 4, right, I see the same distance both sides, right? So that simply means depth of this 7 to 2 and this 4 to 2 is same, right? In this case what you need to do, return 2 from here, okay, and one depth from here, one depth from here, so both are same. So here depth will be incremented by 1, right? So from 5 now you see 2 and 7, right? From 5 you see 2 and 4, right? So 2 is the common for this 7 and 4, okay? Right? So from here I'm returning 2 and 2, right? 2 is the depth, okay? So this is what I'm returning, right? Now same way here, if you see from 5, here this side 6 and 1 I'm returning, from this side I'm 2 2 I'm returning, okay? So among them max is depth is 2, right? So I have to pick this one, just simply return this same node and same depth will be incremented by 1 2 3, okay? Same way from here you are going to return 0 comma 1 distance, here you are returning 8 comma 1 distance, and both are same. So here you are returning 1 at 2 distance, and now here you are returning 2 comma 3, here 1 comma 2. So this is max distance is 3, so this is what you are returning. So 2 comma 4, this is what you are going to return, okay? So 4 is the max depth, right? So 1, then we move here 2, then 3, here we move, right? And then until here we reach, so 4, okay? So 4 nodes I see from here, 1 2 3 4, okay? So 4, but here this is what I need to return, okay? 2 is the subtree, right? 2 is the subtree, right? So that's what we need to do, okay? So you can do one thing here, right? If you still don't get it, right, you can do one thing here. I just keep it very short this time, right? Reason is because this question is similar to this 1123 problem, right? Lowest common ancestor of deepest leaves, LeetCode 1123, right? So in this I have explained this in detail, okay? what is happening, or this tree diagram. Okay, so if you want, you can watch it from here, right? And code is also very same for this, right? So here, let me show you this 1123, right? So I told you that what we need to do, we have to return a result, and our result should consist of two things. One is the node that we need to return, right? And the depth, right? Because we need to keep the max depth in the end, right? So this is what we need, right? So you can do one thing, you can keep it anywhere, you can keep it here, or you can keep it here outside the class, right? But make sure that this should not be private in that case, right? This thing. Now this is your main class, right? Same here, I told you that this is your method, right? So what you need to return, you need to return that particular subtree, right? The order will be same, right? So here I'm going to get the sum result, right? Result is having node and depth, these two values, but I need just node, right? So if I know this node 2, I will simply return 274, right? So helper is going to solve this complete thing for me and get me this node. Okay, so helper of root and dot node I'm going to pass. So if I'm going to pass this node, so it is going to contain complete 2, then 74. Okay, then from here I'm just simply returning result, right? Now after this, I just need to write the code for this helper method. Okay, so same, I'm just copying everything from here in this example 1123, right? So here just copy this and you can paste it here. Okay, here, that's it. Okay, so here what I'm doing, initially if a root is equal to null, then simply return new result null 0, right? That's it. And we are checking the left side, we are checking the right side. So in both the sides, I'm just going to pass helper, I'm going to call root dot left and helper root dot right. So helper goes here, right? Then again it goes here, then here in this and this side, both side null coming for 6, right? So same depth. So from here I'm just going to return what, this root, right? And the depth is 0, right? And plus 1. Okay, so left dot depth plus 1, right? So if both are matching now, if left dot depth and right dot depth both are matching, right? Like just in case of 2, then in that case we are just returning the root node. Okay, but if left dot depth is greater than right dot depth, then we are just passing left node. Okay, so all these things I explained in 1123 problem. Okay, same way, if left dot depth is smaller than right dot depth, then we have to return this right dot node. Okay, so that's it, just run it and just submit it. That's it. Okay, so since we are traversing over all the nodes just one time, so time compressed is going to be off, and that's it. Okay, so I hope that you guys are able to understand this problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.